This is Algebra 2, Lesson 8-5, Adding and Subtracting Rational Expressions. A complex fraction is a rational expression that has at least one fraction in its numerator, its denominator, or both. The example I've shown here is a very complex fraction. You have x plus 3 divided by x squared minus 2x plus 1 plus x over x squared minus 3x plus 2, all divided by x squared minus 4x plus 4 minus 2 divided by x squared minus 4. And yes, we will learn how to do problems such as these in today's lesson. To add or subtract rational expressions with different denominators, you must write them with a common denominator. You can't, it's just like regular fractions when you were a young child and you learn how to add 1/4 to 2/5. You had to get a common denominator between 4 and 5. That's just required, even if they have variables. It is easiest to use the least common denominator, so to find this, you find the least common multiple of the denominators. If you have several expressions, the easiest way to find the least common denominator is to factor the expressions, numbers or polynomials, completely, and then the least common multiple is the product of your prime factors, each raised to the greatest power that any one of them occurs. So let's find the least common multiple. If we have the following expression, 4x squared minus 36 and 6x squared plus 36x plus 54. If we want to find the least common multiple, the first thing we're going to do is we're going to factor out each one of these expressions. So if I have 4x squared minus 36, if I factor this, I'll take a 4 out of it, and I get x squared minus 9. And if I factor that a little further, I get x plus 3 times x minus 3. And if I take my 4, that's going to be 2 times 2 times x plus 3 times x minus 3. So that would be 4x squared minus 36 factored down to absolutely all its prime factors. Now I'm going to do the same thing with 6x squared plus 36x plus 54. First thing I'm going to do is notice that it has the greatest common factor of 6, so I'll take that out. I'm only left with x. Oops, not x. It's not 6, it's 3. It's got a greatest common factor of 3, so that'll be 2x squared. Oh, wait. How if I write the column down right? Let's start over. That was 6. I was right. It's 6x squared plus 36x plus 54. I forgot my 3 the last time, or my 6. So take a 6 out, you get x squared plus 6x plus 9. Now I need to factor out x squared plus 6x plus 9, and that would factor to x plus 3 times x plus 3. And then my 6 will factor down to 2 times 3 times x plus 3 times x plus 3. So there's the completed factorization of that expression. Now, the next thing I like to do is I like to write these expressions over each other. So I'm going to have 2 times 2 times x plus 3 times x minus 3. And then I have 2 times 3 times x plus 3 times x plus 3. I do this because then I can look and say, what do they have in common? Because what they have in common, you only need to take once. So they have a 2 in common, so I need to take that once. They have these x plus 3s in common, so I need to take that once. But now I need to take everything else they have as well. So my greatest common, my least common denominator, or my least common multiple, would be everything that I have boxed once and everything that I have circled once. Which means the least common multiple is 2 times 3 times x plus 3, we only need one of those, times another x plus 3 because we need the second one there, times x minus 3. One out of this group, but you also have to have this second one here. Now you don't have to multiply this back together, except for the numbers maybe, because 2 times 2 is 4, 4 times 3 as well. So we have 12 times x plus 3 squared times x minus 3. That would be the most simplified version of the least common multiple that you need to have. Okay, so you take it, you factor it, you find out what they have in common, group what they have in common, and take one of each one of those things. Everything they don't have in common, take one of those as well. So, to write on, I actually wrote it all in the same spot. The least common multiple of the denominators of two rational expressions is also the least common denominator of the rational expression. And you need the least common denominator to be able to add and subtract rational expressions. This number 2 here is, I forgot to write them down here. I did it over to the right. So it's the same thing, but over to the right instead. All right, so adding rational expressions. What is the sum and stated restrictions on the variable? So the first thing we need to do here is we need to find the least common multiple, or the common denominator, whatever way you want to call it. So I'm going to look at this, I'm going to factor my denominators. I tend to factor right underneath if I can. So I'm going to have x plus 4 here times x plus 1. Here I can take out a 3 and I get an x plus 1. So now I look at this and I go, they have an x plus 1 in common, so I need one of those. They have nothing else in common, so I need everything else that's left, which means I need an x plus 4, and I need 3. So there's my common denominator. 3 times x plus 3 times x plus 4. Then I look at this first expression. The 1 over x plus 4 times x plus 1 has the, how did I get an x plus 3? That should be x plus 1. X plus 1. Okay, so the common denominator is 3 over x plus 1 times x plus 4. This particular expression here has the x plus 4 and the x plus 1. The only thing it is missing is the 3. So I'm going to multiply the 3 times the 1. Keep my plus sign. This expression here has the x plus 1 and the 3. It's missing the x plus 4. So I'm going to have my 5x. I'm going to multiply that by x plus 4. All you do is take the numerator and multiply it by what it's missing in its denominator. If you look at the denominator that you have here, okay, we have, this is my denominator here. It was missing the 3, so I took that 3 and multiplied it by my numerator. This denominator here was missing the x plus 4, so then I had to multiply that x plus 4. Now we can simplify. So now I'm going to have 3 times 1 is 3. 5x times x plus 4 is 5x squared plus 20x. And that's still all over 3 times x plus 1 times x plus 4. Last but not least, let's put it in standard form, because sometimes when you put it in standard form, you can simplify it even further. So now I'm going to put it in standard form. 5x squared plus 20x plus 3 all over 3 parentheses x plus 1 times x plus 4. And I know the 5x squared plus 20x plus 3 does not factor again, so I'm done there. But now the last thing I need to do is state the restrictions on my variables. So I look at my denominator, and x cannot equal -1, and x cannot equal -4. So there's the simplified version of that with its restrictions. There we go, is number 1. We have x plus 1 over x minus 1 minus 2 over x squared minus x. And so, again, factor. This first expression doesn't need to be factored. The second expression, I can take an x out, and I get x minus 1. So my common denominator is x times x minus 1. Because this has an x minus 1, this has an x minus 1, and this has an x, so we have to add that in there. The first expression is just missing the x, so I'm going to multiply x times x plus 1. The second expression is missing nothing from the denominator, so I can just leave it as -2. So I can simplify here. I get x squared plus x minus 2 all over x times x minus 1. And I look at this and go, can I factor that numerator now that it's been combined? Yes, I can. I can factor this numerator up here. X squared plus x minus 2 will factor to x plus 2 times x minus 1 all over x times x minus 1. So the x minus 1s will cancel. So this will simplify to x plus 2 all over x. But my restrictions are x cannot equal 0 and x cannot equal 1. There's the simplification of that particular problem, along with its restrictions. Number 3. Let's see the way you want to look at it. Letter C. X over x squared minus 4 plus 7 over 3x plus 6. Okay, again, factor. This factors to x plus 2 times x minus 2. This factors to 3 parentheses x plus 2. So my common denominator would be x plus 2 times x plus 2 times 3. Okay, so 3 times x plus 2 times x plus 2. So in my first expression, I have the x plus 2's and the x plus 2, x minus 2. I didn't even use my own handwriting. There we go. So let me write this next one. We're going to have 3 times x plus 2 times x minus 2 as my common denominator. So this has the x plus 2 and the x minus 2. It's missing the 3, so I have to multiply the 3 times the x. Plus, the 7 is missing the x minus 2, so we'll multiply that by x minus 2. So on the numerator, you get 3x plus 7x minus 14 all over 3 times x plus 2 times x minus 2. Simplifying that numerator, 3 and 7x is 10x minus 14 all over 3 times x plus 2 times x minus 2. Now I can factor my numerator, but I know the only thing I can take out of it is a 2, and I'll be left with x minus 7, so nothing simplifies, so there's no point in factoring out that 2. So I will leave it like that, stating my restrictions. My restrictions are x cannot equal positive and negative 2. Okay, subtracting. If you remember, subtracting is the same as adding the opposite. So you need to make sure you run through variable through the entire second half of the problem. There are several ways to do this in which that I do it so that I don't forget to run that negative through. And you can just choose which way you like better. I will show 2 different ways that I do it so that you won't forget to run that negative through. All right, in this first expression, 2x over x squared minus 2x minus 3 over 4x plus 4. Again, factor it. So this will factor to x minus 3 times x plus 1. This one will factor to 4 parentheses x plus 1. So my common denominator is going to be 4 times x plus 1 times x minus 3. In the first expression, we have the x minus 3 and the x plus 1. We're missing the 4, so I have 2x times 4. In the second expression, I'm missing the x minus 3. Now, I could do this very easily by just saying plus a negative 3 parentheses x minus 3. That takes care of the subtraction sign right here because I added the opposite. If it's only one term, that's really easy. You just change this to this, change that to that, and then when you run the negative through, when you multiply, it takes care of subtracting everything. Excuse me. That's probably one of the easiest ways if the term is only one term. It's only a monomial, it works really well. Now we can just multiply like usual. So I have 8x minus 3x plus 9, because I just ran this negative 3 through this expression. And that is all over 4 times x plus 1 times x minus 3. And now I'm going to simplify. 8x minus 3x is 5x. So I have 5x plus 9 all over 4 times x plus 1 times x minus 3. And my restrictions are x cannot equal negative 1 and x cannot equal positive 3. Looking at number 2, or letter B, I should say. Let's factor this. I'm going to take a 3 out of this. That's going to leave me with x squared minus 3x plus 2, which means that I can factor that to x minus 3, x minus 2, x minus 2, x minus 1. Okay, over here, I can take 3 out of this. I get x squared plus x minus 2. So that will factor to x plus 2 times x minus 1. So my common denominator then. Each one has an x minus 1. Each one has each one has a 3. And this one has an x minus 2. And the one on the right has an x plus 2. So there's a big common denominator there. So if we look at the first expression, we have the 3, we have the x minus 2, we have the x minus 1, we need the x plus 2. So I'm going to put down the x times x plus 2. Now in this case, to run the negative through, I'm just going to do a little bracket here. This is the second way of doing this. So that when I multiply by whatever I'm missing, I know that eventually I have to run the negative through that entire expression. So it has the 3, it has the x plus 2, it has the x minus 1, it's missing the x minus 2. So I'm going to do a 2x plus 1 times an x minus 2. So there's the setup for that. Okay, so I multiply this through x squared plus 2x. I'm still going to keep my minus. I'm going to keep my big giant parenthesis. When I multiply 2x plus 1 times x minus 2, I'm just going to keep that. I'm just going to multiply it out. So I'm going to get 2x squared minus 4x plus x minus 2. All over 3 parentheses x minus 1 times x minus 2 times x plus 2. At this point in time, I can run that negative through, which I will. So I will have x squared plus 2x minus 2x squared plus 4x minus x plus 2 all over 3 parentheses x minus 1 times x minus 2 times x plus 2. I know a lot of people try to tell me, why can't we just combine and do that negative at the same time? Some people can do that. Most people cannot. They mess something up and they miss a step, and then it gets really ugly. So I do it step by step by step because I don't like to miss steps. Now I can simplify x squared minus 2x squared is negative x squared. 2x plus 4x is 6x minus x is 5x plus 2 all over 3 parentheses x minus 1 times x minus 2 times x plus 2. And now I look at the top to make sure there's nothing that can factor out. If I factor out a 1, I'd get x squared minus 5x minus 2. There's no two numbers that multiply together to get 2, but add together to get negative 5. So I'm good. So I just need to state my restrictions. My restrictions are x cannot equal positive and negative 2, and x cannot equal 1. And there you have the simplification. Just remember, when you subtract, you have to subtract the entire second term, which is why back here in this step right here, I made sure that I left that negative outside of that parenthesis, which means that here in the very first step, I made sure that I put it in as a bracket rather than as a parenthesis, so I didn't get that confused. All right. Now, complex fractions. There are two ways to simplify complex fractions. You can multiply the numerator and the denominator by the least common denominator of the rational expression, or you can simplify them by just taking care of the top part of the fraction and finding its common denominator, taking care of the bottom part of the fraction and then taking its part of the common denominator, and then multiplying that by the reciprocal. Remember, a complex fraction just means it's a division. This basically says 1 over x plus 3 divided by 5 over y plus 4. That's all it's saying. So if you remember from algebra or from basic general math when we dealt with fractions, once you get this answer here, all you have to do is change this to a multiplication problem and then you can write the reciprocal of this answer here. So let's just do this two different ways, and you can choose the way you like better. And then I don't care which way you use as long as you get the correct answer using one of the different ways. The first method is to find the least common denominator of all the rational expressions. So if I have 1 over x plus 3 divided by 5 over y plus 4, the common denominator of both of these, if I put a 1 under this and a 1 under this, I would need the common denominator of x, y. So I'm going to take this entire fraction up here and multiply it by x, y. And I'm going to take this entire fraction down here and multiply everything by x, y. Because all we're doing is finding the least common denominator of the entire rational expression. Now, if I distributed this, this would be 1 over x times xy plus 3 over 1 times xy divided by 5 over y times xy plus 4 over 1 times xy. And I'm doing this horizontally because I'm running out of space if I don't. I normally do it vertically, but I didn't leave myself enough space here. Okay, so now, if I was to simplify this cancels with this, right? This cancels with that. So what I have here is I have y plus 3xy divided by 5x plus 4xy. Now it's a basic regular division problem. And I just look to see if there's anything that can simplify, and there isn't. So I'm done at that point in time. So I have y plus 3xy over 5x plus 4xy. And we're done with this problem at this point. That's method one. That works pretty well if your problems are small. If your problem has a ridiculously large least common denominator, it gets very, very, very complicated. I actually prefer method two, but it doesn't really matter which method you prefer. Just pick one that you like. Method two says you take, I have 1 over x plus 3 divided by 5 over y plus 4. And you just deal with the numerator separately from the denominator. So if I looked at this, I was going to have my common denominator is x. So I need to multiply this by an x. Okay, so that because my common denominator is going to be x. So I have 1 plus 3x. Because my common denominator was x. And the denominator, at the bottom, my common denominator is y, because this is over 1, so I need a y. So it's going to be 5 plus 4 times y. And then what you do is you keep the first fraction, 1 over 3x, 1 plus 3x over x. Then you multiply it by the reciprocal of the second fraction, y over 5 plus 4y. And then you see if anything cancels out. Right? Nothing does at this point in time. So I get y plus 3xy all over 5x plus 4xy. I get the same answer regardless of how I do it. I don't know if one is any easier than the other. I think I prefer the second method because this is the way I was taught, so I'm used to it. So it's the method I always go back to. So since you may or may not have been taught any methods, I'm teaching you both, so you can choose which one you prefer, and you can just go with it that way. All right, going back to our examples. We just did this problem, basically. If you look at the page in front of it, we have 1 plus 3, right? Look at this. We have 1 plus 3x over x, 5 plus 4y over y, exactly the same problem, so we should get the same exact answer. Right? If I look at this, it already has the common denominator, doesn't it? It's just a basic complex fraction, which means you do this. 1 plus 3x over x and multiply it by the reciprocal y over 5 plus 4y. And you get y plus 3xy all over 5x plus 4xy. That's just showing you that once you get it to this point, all you have to do is keep the top part of your fraction, multiply by the reciprocal of the bottom part of the fraction. Letter B here. Okay. The numerator doesn't have a fraction in it, so I can leave it alone. My denominator, I need to get a common denominator here. So I'm going to have 3 divided by, my common denominator is 2y, so I'm going to have 1 times 2y minus 1 all over 2y. That's my common denominator. My common denominator is 2y. Okay, if I simplify that a little bit further, I have 3 over 2y minus 1 divided by 2y. Okay, so the first fraction is 3 over 1, basically. We're going to multiply it by the reciprocal, which would be 2y over 2y minus 1. Nothing can cancel out. So we just multiply straight across the top, so I think it's 6y. Straight across the bottom, 2y minus 1. And since there are no common denominators, like that. And interestingly enough, with complex fractions, you don't have to state a restriction. They don't make you state a restriction with a complex fraction, so we don't state restrictions with complex fractions. Here we are, letter C. This one's a bit more complicated. Okay. I'm going to look at, I like to do them separately, so I'm always going to do the numerator separately from the denominator. That's just the way I prefer it. So if I look at my numerator has a common denominator of x times x plus 1. This has the x, it's missing the x plus 1, so I have x minus 2 times x plus 1. The 2 has the x plus 1, it's missing the x, so it's minus 2 times x. This is a monomial, that makes it very easy. Okay. The denominator now, notice I made my line bigger so I can tell the difference between the top and the bottom of the fraction, has a common denominator of x plus 1 times x minus 1. The 3 has the x minus 1, it's missing the x plus 1. the 1 has the x plus 1, it's missing the x minus 1. So here we have that. So we've simplified those in the fact that we've got them over a common denominator. Now I actually just need to multiply them out. So if I multiply out the very top, I'm going to get x squared minus 2x plus x is going to be minus x. I'll just do it. X squared plus x minus 2x minus 2 minus 2x. Okay, we'll simplify that in just a second. All over x times x plus 1. Bottom is going to be 3x plus 3 minus x plus 1. All over x plus 1 times x minus 1. These take up space. They're not hard, they just take up a lot of space. So you have to keep them nice and neat and tidy. So then if I simplify that top, I will get x squared minus 4x plus x is minus 3x minus 2 all over x times x plus 1. And then at the bottom, I will get 3x minus x is 2x, 2x, 3 plus 1 is 4 plus 4, all over x plus 1 times x minus 1. So now we've got it simplified to the point now where I can actually just take care of the multiplying by the reciprocal part. So I'm going to have x squared minus 3x minus 2 over x times x plus 1, and multiply that by x plus 1 times x minus 1 all over 2x plus 4. Now before I multiply, now this is just a basic multiplication problem which we did the last lesson. I actually need to see if I can simplify it first by factoring. Right? And you might go, oh my goodness gracious, Mrs. Ryan, why do we have to keep doing this? Well, because it's math. All right, so x squared minus 3x minus 2 is x minus 2x minus 1. So I have x minus 2 times x minus 1 all over x times x plus 1 multiplied by x plus 1 times x minus 1 all over, if I take that 2 out of there, I get x plus 2. So this is what I have. Now I can look and see if anything cancels. Okay. So if I do this, I get this x plus 1 cancels with this x plus 1. Gee whiz, it doesn't look like anything else cancels, does it? Okay. So I can go back to multiplying this together again. Okay, now you're looking at going, holy cow, I have to multiply all this together? Yes. Okay, remembering that this multiplied through that, I have x squared minus 3x minus 2 times x minus 1 all over x times 2 times x plus 2. Okay, so if I multiply this, now it's one part, multiplying it together. Okay, so if we multiply it all together at the top, we're going to get x to the third minus x squared minus 3x squared plus 3x minus 2x plus 2 all over 2x squared plus 4x. And 4x times 2x plus 4, either way works. Now, last but not least, let's simplify the top. So this becomes x to the third minus 4x squared plus x plus 2 all over 2x squared plus 4x. Yes, that was a very long, complicated, complicated problem. It took a lot of steps, but that's what happens when they get really big. They take quite a few steps. And if you skip steps, you're most likely going to make an error somewhere. And you do not want to skip steps, because when you skip steps, things end up getting really ugly, and then I can't figure out where you made the mistake. I just let you get the answer wrong. So show all your steps. This isn't hard. It's just time-consuming. Okay? Tedious and time-consuming, but important, because you have to be able to do these types of things, because they do require you to think logically and process information logically.